everybody. Objective 1B is on understanding the difference between an ideal gas and a real gas. In the real world, no gas acts ideally. We make some assumptions about gases and pretend that they act ideally for our calculations to make things easier, but in reality, that just doesn't happen. So as the temperature of a gas increases and the pressure of a gas decreases, the gas starts to behave more ideally. In Objective 2, we're going to learn about the ideal gas law, but I will tell you right now the ideal gas law is PV equals nRT. So if we divide PV by nRT, it should equal 1, and this is where our ideal gas behavior is. As you can see from the actual gas behavior, it does not behave ideally. We're going to assume for our purposes, for our calculations, that it does. However, you do need to understand the differences between real and ideal gases. So we'll start out with everything that's the same about them. Ideal gases are made up of small particles that have mass. They are mostly empty space. They have low density, and the gas particles are in constant random straight line motion. These are part of the kinetic molecular theory, and they are the same for ideal gases and real gases. There are a couple of really important differences between ideal gases and real gases. In an ideal gas, there are no attractive or repulsive forces between particles, but in reality, real gases have very small attractive and repulsive forces between particles. In ideal gases, we assume that the particles have no volume because it is such a small volume. But real gases do have a very small volume, which changes the calculations. In dealing with ideal gases, collisions between molecules are completely elastic, which means when they hit each other, they lose no kinetic energy. In a real gas, collisions between molecules are inelastic, so they do lose a small amount of energy when they hit each other. And as you can see, our ideal gas law equation is PV equals nRT. The real gas equation is a bit more complicated. So all of the calculations that we make will be based off of ideal gases.